Hello students, today again we will solve very important question, and these questions will come in your CAT 2 exam. Similar question will come, and in this lecture we are explaining many topics, and we will also show same topic we cover in our class presentation, and similar question will also come in your CAT exam and C exam. So today we will cover many topic. Okay, so total number of topic we will cover. Actually we are solving all the topics. Number first is ambiguous, and second is context free language, post down automata, Turing machine, closure property, and PDA to CFG, PCP, CSL, context sensitive language, and this is the undecidable problem, recursive enumerable language, pumping lemma for both regular as well as context free, all type of language just like type 0, type 1, type 2, type 3, and CFG to CNF. Okay, so most of the topic we will cover today. So if we'll cover this, if you'll watch the video, then this is our 100% guarantee you will get 100 out of 100 marks in your exam. So today first question, what they are asking the first question, S produce A as A or B as B or A or B, and he is asking what is the grammar. Now at first you should write S produce terminal, okay, A, S produce terminal B. I am writing separate here. Done. Next I will use both one by one. I am writing S produce A S A. Okay, then again I am writing A, okay, S produce A S A, okay. Now next we are writing S produce A, S produce B S B, and this is A. Done. Because S produce B S B also. Now I can stop anytime because these are the terminal. I am using this terminal A B. Suppose I am writing A in place of S, B A. Okay, now if you'll see this one this side and see this one this side. This is AAB and this is BAA. What is the meaning of this? This is my W and this is my WR. Means this is the reverse of my W, and this is the middle one. Either here you can write A because this is S. In place of S I am writing A. I can write either A or B. Okay, done. What is the length of this? Total 1, 2, 3, 4, 5, 6, 7. If you will see, every time odd I am getting. Okay, I am writing only one, but you can check also. So this is the odd palindrome. Okay, this is the odd palindrome. So the final answer in the exam you will write this grammar is the odd length of palindrome. Getting? This is the answer you will write in your exam. And if you will see, during our class presentation also we solve same question. Okay, now I am coming to second topic. What is the second topic? Determine the grammar. Okay, here S produce AB or AAB, and A produce A or AA, and B produce B. It is ambiguous or not. Okay, for this string AAB, I will suggest you one thing. If you will check GATE 2026, similar question also came in your GATE exam. Check, you can check also. And this question came in your last year, AAB. Now what is the meaning of ambiguous? Ambiguous means if you are able to drive more than one tree, that is the meaning of ambiguous. Otherwise it is non-ambiguous, means two ways to drive the string AAB. Okay, that is the meaning of ambiguous. Now you can see that S drive AB means S produce AB. Now if I am taking S produce AB, now I am using from left to right. Now you can see A produce either A or AA, and what is my target? My goal is AAB. I am taking A produce AA. So in place of this A, I am writing this one AAB. Okay, in place of A I have written AA. Now what is my goal? My goal is AAB. I want A at first. Now here I want A. Okay. So what I will do? A produce A. So I will keep this information here. So B. So what is my target now? I want B here. Okay. Because our goal is AAB. Okay. Now see here, B produce B. So in place of this I can keep AAB. So at last I got my final answer AAB. So this is a one way to get my string. Okay, now I will try to find another way. Is there another way? If I am taking this another AAB, what will happen? See here. I think that you are getting. So if I am taking AAB, and what is my goal? My goal is AAB. This is my goal. You can see also B produce B. If directly I am writing B produce B, I am getting AAB. Now you can see there are no total number of B produce B. There are no total number of 2 ways to get my string. So that means this is the ambiguous. This question also came in your GATE 2026. Okay, I think that you understand. Now we are coming the third topic. This is very important. Third topic. What he is asking, give the closure property of the context free grammar, okay, or language. If you will see our class presentation, this is our class presentation, and in the class presentation we proved all question, okay, why, all why. Now we explain about the regular language as well as DCFL, okay, means deterministic context free language and non-deterministic context free language, CSL. This is the context sensitive language, and this is the recursive, and this is the recursive enumerable language. We solved for the union as well as intersection, difference, complement, concatenation, Kilni star, Kilni plus, as well as reversal. So why? So in this question you have to write, if two languages are two L1 and L2 are CFL, then its union is not CFL. Okay, its union is not CFL. Also intersection is not CFL. Also difference is not CFL. Okay, you have to learn this. Why we explain here? Okay, why we explain here? Okay, if this is DCFL, we explain here. DCFL means you are using only one stack. Okay, if there is one comparison, then you are using one stack. One comparison, you are using one stack. And if I merge, okay, means I take union L1 union L2. Now I am getting total number of 2 comparison. So more than one comparison means this is not DCFL. So L1 union L2 is not DCFL. Okay, for this problem. So similarly, many questions we solved during our class presentation. Now next question, what he is asking, in PDA, the language accepted by finite state and empty stack both are same. You should remember, the PDA that accept a language by finite state, there exists an equivalent PDA that accept the same language by empty state stack also, vice versa. Okay. Now next question, what he is asking, in the definition of PDA, if you will see, there are total number of 7 tuples, and what is the representation of Z0? If you will come to our class presentation, already we defined the meaning of Q means set of state, Q0 means start state, and this is the transaction, and this is the final state, and sigma means set of inputs, and this is the stack symbol, and after then Z0 means this is the stack starting symbol. So we solved many questions during our class presentation. So here we are asking only 1 marks question. Now another 1 marks question, push down automata is more powerful than this. Already we told last time in our class presentation, type 0 means recursive enumerable language, and what is the model? Model is Turing machine. And type 1 means context sensitive language. What is the model? Model means linear bounded automata. And type 2 means context free language, and what is the model? Model means PDA. And type 3 language means regular grammar, its model is equal to finite state machine. And if you'll see here, type 0 is greater than, type 1 is greater than, type 2 is greater than type 3. So also we explain also during our class presentation, the finite state machine is the inner. Okay, then upper, this is a higher level language, PDA. So PDA is more powerful, CSL is more powerful, and Turing machine is more powerful. Okay, so already we explained, we solved many questions during our class presentation. Now we are coming to the next topic. What is the next topic? He is asking what is the context sensitive grammar production. We told you that. Okay, number one, the Turing machine that accept recursive enumerable language. Okay, so what is the meaning of this? If a language that accept Turing machine, okay, it will halt. Okay, if it is accepting, means for the accept condition it will halt, but for the outsider, means the rejected part, okay, that is not in my language, so maybe it is halt, maybe not halt. Such type of language is recursive enumerable language, means the language, but it may not halt or loop forever if the string is not in the language. This is outside. For the outsider, okay, maybe it will be halt, but for the insider, okay, means this is the part of my language, this is the rejected part, okay, this is not part of my language. So for this, maybe it will halt, maybe not halt. That is the recursive enumerable language. Now next question. This question we also asked during our last time, and express the context sensitive grammar production. Okay, and here you have to remember this. Okay, alpha, A, here alpha and beta are the string and A is the non-terminal, and here A produce this gamma. Okay, so this grammar means this production, okay, you have to write in your exam for the context sensitive language. Context sensitive language, what is the model? Linear bounded automata, remember. And what is the example? A ki power n, B ki power n, C ki power n. This famous example for the context sensitive language. Why? Because to complete this we are using number of 2 stack. Okay, already we explained during our class presentation. Now next he is asking two Turing machine, and what are the 2 ways the language accepted by push down automata. Okay, 2 questions. Before it, you should also remember this graph, you should design it actually. Okay, whenever we are asking any such type of question, you should design the graph. 100% you will get the marks. So for this A star or a string that contains 0, a string, a language that contains 0, or any language that start with 1, end with 1, and such type of question, many questions we solved during our class presentation. These all are the regular language. And what is the upper language? This is the context free language. This is the upper language, and examples are A ki power n, B ki power n, WWR. This is the famous or famous example. And another one, Turing machine. This is the upper level language. Actually this is A ki power n, B ki power n, C ki power n. This is the context sensitive language. It means accepted by context sensitive language. Turing machine can solve any problem, this problem as well as this problem as well as this problem. Already we explained during our class presentation. So Turing machine is a higher level language. It can solve any type of problems that are inside this you can see that inside this subset. Okay, now see here, you should also remember this graph. Regular language, upper is context free language, upper is context sensitive language, upper is recursive language, upper is recursive enumerable language, upper is non recursive enumerable language. Okay, so this graph also you have to remember. Okay, this will come in your exam. Now he is asking total type of Turing machine. If you see what is Turing machine, the Turing machine, this is the state actually. Okay, so if a tape is pointing this state, a tape is pointing this state. This tape either it can move left or right, only one. Okay, either one, it can move one state to another state only one time. Okay, either left or right. Okay, so this tape is pointing here. If you will move here, then it will point here. It will move left, then it will point here. So it can one step by step. That is the text processing. You are reading all the text one by one. Okay, so there is a one tape in the simple Turing machine. There is only one tape, and if a person is taking such type, we can also design such type of Turing machine where there are the many tape are here. Okay, multiple tapes are here. What we have written, multiple tape Turing machine features multiple independent tapes. Okay, each with its own read write head. Okay, which allow for the parallel processing. Okay, you can see that in this graph also we explain there are multiple tapes. Similarly, there are other Turing machine just like multi-track Turing machine, multi-head Turing machine, non-deterministic Turing machine, universal Turing machine, semi-infinite tape Turing machine, multi-dimensional Turing machine, enumerator Turing machine, probabilistic Turing machine. Means according to the, if you know the data structure, then you can understand. But we will try to solve later what is Turing machine and how to solve the problems by using Turing machine. Later I will, because this is only 1 marks question. Okay, so you have to write only this one. You have to write any two, and in exam also you have to write only two, the name of the Turing machine only. Okay, you have to write only, no need to write this text. Okay, now we will come to our main part. The main part is the descriptive part, and here you have to explain the question one by one. Okay, so now students, this is the second question. What he is asking in the section number B, this is the descriptive question. In the descriptive question he is asking, if X produce AX, AZ or BY, and Y produce A or AX and or BY, BYY, and Z produce B or BX, AZZ. Now he is asking for the string, this string, it is ambiguous or not. Again I am saying similar question also came in GATE exam. Okay, so 2026. So this question is very important, and same question also came in your semester end exam. Now if we are able to find, there are total number of 2 tree, okay, more than 1 tree, then this is ambiguous. Otherwise this is not ambiguous for this string. So this is our target. Now I will try. At first I am taking this one, X produce AZ, X produce AZ. So I am taking X produce AZ. Okay, now in place of this Z, in place of this Z, I am writing this one because Z produce AZZ. Okay, so in place of this I have written Z produce AZZ. Okay, I am writing in this form. Now next AA already done. Okay, what is our target? AA already done. Okay, now in place of this Z, in place of this Z, I am writing again AZZ. Okay, so in place of this Z, I am writing again AZZ. So now you can see after this 3A completed. Okay, so now we have ZZZ. I want B. I want B. What is our target? I want B. I want B. I want this B. So in place of Z, I am writing B. Okay, Z produce B, because already we know that Z produce B. So now Z produce B. Now we have 2Z. So up to this we found. Now again I am writing in place of Z, we are writing Z produce B. So this also be done. Okay, now we have at last only one Z. Okay, A and B we got. Now again in place of Z I am writing AZZ again, because in place of Z AZZ you can see. Okay, Z produce A Z Z. So in place of Z I am writing A Z Z. Now after then what is our target? Our goal is this we got because of Z produce A Z Z. Okay, so A I got. Now I want B. I wanted this B. How to get B? In place of Z I am writing B. Okay, in place of Z I am writing B. Okay, in place of Z I am writing B. Done. Now this goal also done. Now we have only one Z. We have only one Z. If you will see, Z produce also Bx. Z produce also Bx. So now I am writing in place of Z I am writing Bx. Okay. Now up to this also I got. Okay. Now X. What X produce? X also produce By. X also produce By. Now X produce By. In place of this X I am writing By. Now I also got this one. Now at last Y produce A. You can see Y produce A. So at last I am writing this one. So all we got. Okay. This is a final. I got this string. So I by the help of one tree. Okay. This is a one tree. Now second tree I am trying. Suppose I am using another color here, so it is very easy to understand. Now first I am taking Z produce AZ. Z produce AZ. Okay, this already we done. Z produce AZ. Okay. Now in place of Z I am writing AZZ. AZZ. Okay. Up to this same. Okay. So we got this A as well as we got A. 2A we got. Now in place of Z I am writing AZZ. In place of Z I am writing AZZ. In place of Z I am writing AZZ. Now in place of Z I am writing AZZ. So I got this 3A. This 3A I got. So now we have ZZZ. Now once we are writing ZZZ here, in place of Z I am writing BX. Okay. And if we will write the same thing, at last we are getting our this outcome string. Okay. Now if you see, this is the step number 4. And in my previous code, step 1, step 2, step 3, step 4. In my step 4, I got this BZZ. Okay, I am not writing X. I am not writing X. So now you can see at step 4, I am writing BX. Z produce BX. Z produce BX. Z produce BX. So this string outcome, I am using one derivative tree, and this string at last I am getting this final answer by the help of another derivative tree, because at step 4 this tree at step 4 Z produce Bx I am taking. So this tree is different. Okay. So this is the final answer. So this is the ambiguous. Now I will come to the next question. What is the next question? I am taking the next question. Okay, what is the next question? Prove that the language AN, BN, CN, N is greater than or equal to is the context free language or not, using the pumping lemma. Okay, this is very important. If you will see our class presentation also, we solved this question. Again I am writing, I will solve this question by two methods. Okay, today I will explain two methods. The pumping lemma is a fundamental theorem in automata that is used to prove a language is regular or not context free. Okay, so I will solve when it is not regular, when it is not context free. I will solve both. So first I am solving this one. Suppose this time we will ask this question in your exam. Okay, n is greater than or equal to 1. Prove that this is not regular. I am solving this question at first. Okay, so to solve this question, I am writing some restrictions. If I am able to divide the string in 3 parts, for this, suppose I am taking one substring of this language. Okay, and suppose this is A and B, suppose I am taking this one. Okay, this is my one string. If I able to divide the string in 3 parts, What is the meaning of this? Rule number 1. As I able to divide this in 3 parts, yi, z belong to my language for all every value of I. Rule number 1. Rule number 2. This y, its length must be greater than 0. Rule number 2. Rule number 3. What is the rule number 3? My xy length, this xy length, it must be less than this x and y. It must be less than equal to p. What is p? You can take any value p. Here suppose I am taking p is equal to 3. P is equal to, suppose I am taking, you can take any one. Okay, here I am taking, suppose 3 is very less. Okay, you can take 1, 2, 3, 4 I am taking. Okay, I am taking 4, or 3 you can take. Okay, I am taking 3. Now fourth one, the length of xy always be the subset of xyz. Okay, these 4 conditions you have to fulfill. Now my string is s is equal to a b b b. This is my string. Okay, now let I am taking, this is my x you can take epsilon also, no problem. Okay, now y must be greater than 0 and xy must be less than p. Okay, suppose I am taking, this is my x and this is my y and this is my z. Done. You can take any, any form. So what is the meaning of this? My x length is equal to 2 because x is equal to 2, because x is equal to a. Okay, so x length is equal to 2. Y length is equal to 1. Okay, why? Because y is equal to a. And z length is equal to 3. Z length is equal to 3. Why? Because z is equal to b. Okay, I divided in 3 parts. Done. Now you can see, what you can see, my y is equal to 1, that is greater than 0. It means that the first one pass. This also I able to divide the string in 3 parts. Done. Now xy length, if I am taking both x and y, okay, what is x and y? My x is equal to a and y is equal to a. This length is equal to 3 and it is less than equal to 3. Done. So this is also correct. Okay, this is 3 and this is xyz is total number of length is equal to 6. Xyz is, this is xyz. Okay, this is my string xyz. I able to divide in 3 parts. Okay, so now this is a subset of this one. Okay, now see here, I will prove this one now. S is equal to x y I z. Now your s is equal to x y I z. Okay, now see here, I am not taking I is equal to 1, I am taking I is equal to 2 because I is equal to 1 already satisfied. Now see here, x y square z. Okay, now what is x? Your x is equal to a. X is equal to a. Done. Now what is y? Y is equal to a square. What is z? Z is equal to b. Done. Now see here, my a square means a and b. Now see what is going on here. My total number of a are 4 and b are 3. So number of a is not equal to number of b. So this does not belong to my language. Now what is the meaning of this? So this fail. Okay, what is the meaning of this? It must be belong to L. After dividing my string in 3 parts, if for all value of I it's belong to L. Okay, then this condition satisfy. Okay, but this condition not satisfying. Not satisfying means this is not regular. This is not regular. What is not regular? This a ki power n, b ki power n is not regular. So maybe this time we can ask this question. Okay, now I will solve another question. Now I will rough it. I think that you understand. If you understand, I will show some magic here. Okay, easily in exam you can understand, no need to remember. I will copy and paste the above part, and see for the context free language also we will use the same method. Okay, so in exam what we ask, now same method I am writing again. Now see here, I am writing same method. Okay, I am using another color. Suppose I am using this color. Okay, now the language is equal to L is equal to a ki power n, b ki power n, c ki power n is greater than equal to 1. This is the problem. Okay, we have to show this is not what he is asking, this is context free or not. Okay, this question. Now see here this language. Now the first one I will copy and paste from here. Here I have written s is equal to x, y, I, z. In place of this I am writing s is equal to x, y, I, z, p, I, q. Okay, you can write anything. No need to copy this one. It must be belong to L for all I. Condition number 1. Very simple. Condition number 2. Okay, y must be greater than 0. Okay, y must be greater than 0. So here also, if you will see in our class presentation also we have written this y and u. Okay, this must be greater than 0. So what is the power of I? My power of I is equal to here y and p. So second condition, my y and p, this must be greater than 0. Okay, in this question y is greater than 0. Why? Because of y ki power I, and here y p greater than 0 because both power I. Condition number 3. Condition number 3, I am taking here x and y must be less than p. X and y, this x and y must be less than p. So now here I am taking these three. I am taking these three. Y, Z, P. Y, Z, P must be less than equal to P. And condition number 4, this Y, Z, P, it will always the subset of X, Y, Z, P, Q. Okay, I think that you understand, both are same. You will see same thing also be explained in our class presentation also. Okay, now see here, I will solve this question. Now let you have to find only one contradiction. Okay, no need to check left, right, middle, something. Okay, now suppose I am taking n is equal to again 3 I am taking. Okay, so suppose my string is equal to A, I am using another color, B, I am using another color, suppose this is this one. Okay, C, done. Let I am taking again p is equal to 3. You can take any value, number first. So now I have to divide this in 5 parts. We have to divide in 5 parts. And you have to remember also your yp must be greater than 0 and yzp must be less than p. Okay, yzp. So what I am doing, I am taking this x, I am taking this is x. Okay, and this is my y, this is my y, and this is my z, and this is my p, and this is my q. Okay, now what is the meaning of this? I am taking my x is equal to a, I am taking my y is equal to a, and I am taking x, y, z. My z is equal to b, and I am taking my p is equal to b, and I am taking PQ is equal to BCCC. You can take any, okay, but you have to remember only this one. YP must be greater than 0. Now what is Y? Length of X is equal to 2, okay. Length of Y is equal to 1, length of Z is equal to 1, and length of P is equal to also 1, and length of Q is equal to 4. Done. Now next, YP must be greater than 0. YP, what is Y? Now see here, what is Y? Your YP, Y and P, okay, must be Y and P. I have taken 2. YP, this is greater than 0 because you can see Y is 1 and P is 1. So both are greater than 0. Satisfied? Now YZP is less than P. YZP. YZP. What is Y? Y is A. Y is A. YZP. What is Y? Y is this. Z is equal to B and YZP is equal to B. This length is equal to 3 and it is less than equal to 3. So you can see I satisfied this one, I satisfied this one, and this is already 3 is less than 7, 1, 2, 3, 4, 5, 6, 7, 9. This is total 9 length, okay, this is total 9 length. This is length is equal to 9. So YZP is total 3 and YZP length is equal to 3. Okay, YZP length is equal to 3 and 3 is the subset of this one, correct. Now I will see this is satisfying or not. We have to check. I am able to divide 5 parts, okay. Now I will check for all value of I, it is belonging to L or not. I will check one by one. Now what I am taking, I will remove the above part because there is no space. Okay, I will explain here. Okay, now again I am writing here. So what is my question? My question is AAA, BBB, CCC. Okay, so I am taking, let I is equal to 2. Again I is equal to 2 I am checking. So what is my language? X Y square Z P square Q. Okay, now what is X? Check what is X. My X is equal to A. I will write here X is equal to A. Done. Now what is my Y? Y is equal to what is Y? Y is equal to A. Y is equal to A. So A square. What is Z? My Z is equal to 1. My Z is equal to 1. 1 means what is my Z? Z is equal to B. My Z is equal to B. Now what is P? I will check what is my P. My P is equal to B. My P is equal to B. Z is equal to B. P is equal to B. And P is equal to B. B square. And what is Q? Q is equal to BCCC. You can check also. BCCC. Q is equal to BCCC. Now see here. If I square, then I am getting A because of A square, and this is B because of B square, B, and this BCCC. Now see here, total number of A are 4, total number of B are 4, okay. A is 4, B is 4, but C is 3. So this is not belonging to my language. Fail. Once it is fail, if you are able to find only one contradiction, so you should stop it now. Okay. So what is the meaning of this? If you are able to find one contradiction, this does not belonging to this one. It means that this is not context-free language. A pumping lemma is the fundamental theorem in automata theory used to prove a language is not regular or not context-free. Okay. If the 4 condition not satisfying, okay, if you are able to find only one contradiction, the 4 conditions are not satisfying, then this is not regular. And if you are able to divide the string in 5 parts, and if you find the string, if the string does not satisfy the 4 condition, okay, then this is not context free language. Okay, I think that you understand. So if you go in YouTube, there are many people, they have written, they are taking the language from left to right, right to left, middle, something. No need, you have to find only one contradiction. Okay, now we will solve the next question, that is design the PDA WWR. This is a very famous question, and he is asking that DPDA or not. Okay, what is the meaning of DPDA and what is the meaning of NPDA? DPDA means one move, NPDA means many move, more than one move. Okay, now in this question we will show. Okay, now see here. So now student, we will solve the at first DPDA then NPDA. So what is the algorithm? My algorithm is input, then read, then write, or you can write also pop. Suppose we have one example, my language is equal to a ki power n, b ki power n is greater than equal to 1. Let I am taking this example, triple A and triple B. Number of A and number of B are equal. I am using one stack. To start, we have to use one symbol Z. Okay, now I will start here. The first one, at first I am reading from here first. So what I have written, my input. What is my input? My input is A. What is my top of the stack? My top of the stack is Z. So in this condition, I will push this A inside the stack. So this is A, Z, done. Next I am reading A. My input symbol is A and my top of the stack is A, also A. You can see my top of the stack is also A. In this condition, I will push A. Okay, so my stack condition is A now. Next, so maybe it is multiple time because next is also A. Okay, so maybe there are many A, so it will work because this is the loop. Now next, whenever B is coming, whenever B is the input, in this condition, what is the algorithm? What I have to read and what I have to write. So this already input. Okay, there are total number of 3 input. So I read A. Now next, when B is coming, when B is the input, in this condition, what I will do? I will pop in this condition. What I will pop? I will pop A. Okay, I will pop A. This A, my input is B. This A, I will pop. Okay. Now, similarly, this A I will pop. Similarly, there are many B. My input is B. My input is B. This done. Now input is B. Input is B. And top of the stack is A. Then I will pop. I will pop again because this is a self loop. Again I will pop. Done. So whenever my input symbol is this Z. My input symbol is nothing. Okay, my input symbol is nothing. Now you can see I reached here. So after then there is no data. So if there is no data, my input symbol is nothing. In this condition, my stack is Z. You can see my stack is Z. In this condition, I will pop also this one. I will pop also this one. So I reached my final state. Okay. So now you can see this is the PDA. DPDA actually. Why this is DPDA? Question. Why this is DPDA? Because according to DPDA, for input A, the transaction only for the one state. This state name is Q0. Okay, you are going only one state. And for B, you are going only one state. Another for B, you are going only one state. Now we will see the NPDA. In NPDA, in NPDA, what I will do? Okay, I will use another one minute. I will use another one. Okay, I will write here. So at first I will rough it because it is very hard to write. Now I will rough it. Maybe you have written already. Same algorithm I will apply. 1 minute. Now what I will write, my next question is WWR. My next question is WWR. WWR. Okay, this is my next question. So what is the meaning of WWR? Suppose I am taking this example. A, B, A, A, B, B. Okay, so its reverse is equal to B, B, A, B, A. This is the reverse. This is W. Now, again same. What I will do? Again same. What I will do? I am using my stack. Again I am using my stack. So again what I will do? I will start. Initially what I told. This is my stack. So initially my input symbol is A. Top of the stack is Z. So I will push A into my stack. So what is the meaning of this? Top of the stack is Z and I will push A. Now next is B. Now next is B. Input is B. Top of the stack is A. You can see top of the stack is A. In this condition, I will push B into my stack. Done. Next input is A. Top of the stack is B. You can see top of the stack is B. Input is A. In this condition, I will push this one. Okay. So I will push input symbol is A. Top of the stack is B. In this condition, I will push A. Done. Okay. So now I read 3. Now next A. Input symbol is 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 A. Top of the stack is also A. You can see top of the stack is A. In this condition, I will push A. In this condition, I will push A. Done. Okay. So up to this I read. Now next B. Input symbol is B. Next input symbol is B. Input symbol is B. This is already working. And top of the stack is A. In this condition, I will push. Okay. Input symbol is B. So I will push. Done. Now next, this also done. Input symbol is B. Input symbol is B. Top of the stack is also B. You can see top of the stack is B. So in this condition, I will push B also. In this condition, I will push also B. Done. So up to this I read. Now after then I have to reverse. So before reverse, I am doing something also. You can think here 1, 2, 3, 4, 5. Now see here. Suppose you have this string. BA. Because the string may be anyone. I am taking this example AV. I am taking only this example. Maybe my string can be BA. So what is the reverse? AV. Okay. So my first symbol is B. And top of the stack in this condition Z. So what I will do? In this condition, I will push Z. Suppose for this condition. Done. So total are done. Now I will reverse it. I have to reverse it now. Now input symbol is B. Input symbol is B. And top of the stack. What is the top of the stack? Top of the stack is also B. In this condition, I will pop. I popped again. This coming again. Input symbol is B. So this is multiple time. This is Q1. Another state. This is Q1 0. This is state. Now input symbol is B. Top of the stack is also B. You can see top of the stack is also B. And input is also B. For here. Okay. So in this condition again I will pop. Done. Now input symbol is A. And what is the input symbol is A. And what is the top of the stack? Top of the stack is also A. top of the stack is also A, so I will pop, again input symbol is B, I will pop, again input symbol is A, I will pop again. Getting? So because this is a self loop. Now here one question. So suppose this one reverse, okay, input symbol is A, top of the stack is also A. Suppose top of the stack is A, then I will pop. So this is the final. Now next, suppose there is no input, means you reached the final, you read all text and now you are at final. Okay, final means you can see, if you know the C programming, suppose I am writing YOGASH, after then you can see there is this symbol. Okay, so string total length is equal to after then this symbol. Okay, to stop it. So whenever there is no input and top of the stack is Z, you can see in this condition I will also pop it and I read everything. So this is my final state, done. Now in this NPDA you can see what is going on here. For A I am moving Q0 as well as, for A I am moving also Q1 also. So I am moving two state one time. Okay, I am moving two state one time. This is the NPDA. NPDA means multi-move. This is the NPDA problem. Okay, this is a multi-move, and the before I solved the DPDA. Now I will come to the next question. What is the next question? So this already we explained. Now next, and also if you will see our class lecture also we explain NPDA and DPDA both. Now many questions we solved during our class presentation. Maybe this time we can ask this parenthesis question. Okay, this question we can ask. This is very important question. Now I will come to the next question. Next question is convert the following PDA to CFG. This is very important. So here he has asked many one. I will not solve everyone. I will tell you. If you will see our class presentation also we solved the question. Okay, PDA to CFG. We explain everything. So here I am not explaining everything. I will explain something. So now I will come to my main point. What is my main point? My main point is I am taking one example. Suppose I am taking one example. My transaction is Q0 and input is A and this is Q0. You are going to the Q0 and your top of the stack is A. So whenever there are 2, okay, so 2 की power 2 is equal to 4. So 4 production are here. So how you will solve this question? You will write total number of 4 production. Okay, you will write total number of 4 production. First, second, third, and this is the third one, and this is the fourth one. This is the fourth one. Done. Now once you have written this one, I will give you one very best how to remember this one. So now this is the initial F. This you have to write here everywhere. Q0 and Q0. Number first. Okay, this is my first one you have to write here. Now second, this value, this you have to write here. A and A and A. Done. Now next, this value, this outcome you have to write here. A. Done. Now next, after then this value you have to write here. I am using another color so easily you can understand. I am using another color. So this is Q0, this is also Q0, this is also Q0, and this is also Q0. Done. Now next, this value, this value I will show you. This value you will write here, and this value you will write here. Now what is this? A you will write here. I am using another color, so easily you can understand. This A you will write here, A you will write here, A you will write here, and A you will write here. Okay, and this A you will write here. Maybe there is also Z also. You can write here Z A and A and A. Done. Now next total states are in my language. Suppose there is a Q0 and Q1. How many states are here? You can see. So this is actually cross production. So I will write my Q0 2 time, and I will write my Q1 2 time. Done. Now next, this last one I will copy here. Where? I will copy here. I am using another color. So this, what is this? Q0 Q1 Q1 Q0 Q1 and Q1. So last you have to write here. This you have to write here. Done. So now next, the first one. What is the first one? This first one you have to write here. I am using another color again, so it is very easy to understand. Okay, I am using another color. Now the first one you have to write here. What is the first one? My first one is Q0 and Q0 and Q0. Done. I have written. Now here what I should write here. So my total states are 2. Okay, so at first I will write Q0, then I will write Q1, then I will write Q0, then I will write Q1. Done. This is my question is PDA to CFG. Now there is a question. You can see that here I am writing ZZ, XZ. In place of AA I have written XZ. Now you can replace it. Now question is, whenever there is a epsilon is coming or epsilon is coming here, in this condition what you will do? This is okay. And suppose there is only one transaction. Suppose you have like this, del Q0 and BA produce what? Q, and suppose there is a. Now you can see there is only one, so you will write only 2 की power 1 is equal to 2. Only 2 production are here. Okay, same property you have to follow. Done. Not 4, there are only 2. Now next I am solving another one. Suppose there is a epsilon del and Q0. Suppose there is writing B. I am writing B and I am moving left and I am going to state Q2. This is the Turing machine. I think that you understand. Okay, how the Turing machine is working. Similarly, suppose your state is pointing to blank symbol. In this condition, you are writing, don't be silent. Okay, infinite loop. This is the meaning of Turing machine. So now another example, Turing machine. Now you will see clearly, you will understand. A star. Okay, see here. A. I am pointing my Q0 pointing A. Okay. Now A replaced by A and move right multiple time. Once the blank symbol is coming, this blank symbol is coming. In this condition, once the blank symbol is coming, in this condition, blank symbol replaced by blank symbol, and you move to left side. So I read all my text. I am moving to Q1 state. This is a time 0. Okay, I read A. I am at Q0 replaced by A and I am moving right. Done. Now I am here. A replaced by A and I am moving right. Again A replaced by A, I am moving right. Then again A replaced by A. Now once the this blank symbol is coming, blanks replaced by blank symbol and move left. Now you are here. So I read all my text. So this is accepted and this is halt. Halt means either you should accept or reject. That is the meaning of this. Okay, rejection. Now see here, time 0, I am at A, my tab is at A, and A replaced by A, and move right. Done. Now next, I am my input symbol is A, and A replaced by A, I have to move right, but there is no A. This is B, not possible. Okay, halt and reject, that is the reject part. Now what is the meaning of infinite loop? What is the meaning of infinite loop? Now see here, what is the meaning of infinite loop? See here, A replaced by A and move right, B replaced by B and move left. A replaced by A, move right, B replaced by B and move left. So what is the, this is the infinite loop. This is the best example. In your exam you have to write A replaced by A. You can see A replaced by A, move right, and B replaced by B, move left. So in this condition your tab is going left right, left right, left right, left right. So that is the meaning of infinite loop. I think that you understand. So this is enough. Now I will go to another. We have given you many examples. Now I will go to another example. I am writing another example. I will show Turing machine now. Another example. I will show Turing machine. Okay. Now again we are solving another question to understand the Turing machine. So we are taking one famous example, A ki power n, B ki power n, number of A and number of B are same. At last we are using this dollar symbol. So this dollar symbol, you can use also blank sign. Okay. So what is my algorithm? Input, replace and move. Now see here, I will start Q0. At first, I am reading A replaced by X, move right, done. Now I am moving right. Now I am at Q1 state. So there are many A. Every A replaced by A and move right. Every A replaced by A, move right. Now B is coming. Once B is coming, B replaced by X and move left. B replaced by X and move left. Now I am here. Okay. Now when you are moving left, now you are Q2 state. So there is A replaced by, there are many A replaced by A and move left. A replaced by A, move left. A replaced by A, I am using another color. A replaced by A, move left. A replaced by A, move left. Now I am here. Now X is coming. When X is coming, whenever X is coming, okay, X replaced by X and move right. What is the meaning of this? I am here. X replaced by X and move right. Now I am here. Now once I am here, now see here, I am here. Again I am here. A replaced by X and move right. A replaced by X and move right. Okay. Now I am here. A replaced by A and move right. A replaced by A and move right. A replaced by A, move right. Again I am here now. Now once I am reaching here, B. There is any B? There is no B, है because here X. I am here X. Now X replaced by X and move right. X replaced by X and move right. Now I am here. Now B, whenever B is coming, B replaced by X. And move left. When you are moving left, now I am here. When you are moving left, B at this position, X is here. You can see I already replaced. So B replaced by X, then move left. Now I am here at this position. What I will write? X replaced by X and move left. Now I am here. Now here A replaced by A and move left. A replaced by A and move left. Now you are here. Now X replaced by X and move right. X replaced by X and move right. Now you are here. x replaced by x and move right. Now you are here. Now a replaced by x, a replaced by x, a replaced by x and move right, move right. Now there are many x replaced by x, move right, x replaced by x, move right, x replaced by x, move right. Okay. Now b is coming. Whenever b is coming, b replaced by x, b replaced by x and move left, move left, move left. Now you are here. Now here x, actually here x, x replaced by x, move left, x replaced by x, move left, x replaced by x, move left, move left, move left. Now you are here. Okay. So at last x replaced by x, move right, x replaced by x, move right. Here I am here now. Okay, now I am here. We have to reach this position. So how to reach this position? What I will write? Again I am writing here x replaced by x and move right, and move right. So maybe there are many x, all x replaced by x and move right, move right. Okay, move right. Now I am here. Once dollar is coming, once dollar is coming, dollar is coming, dollar replaced by dollar and move left, dollar replaced by dollar and move left. So I am here now. Okay, now I am here. So this is my final string accept. It means that I read all my text one by one. It means that I read all my text one by one. Now there is a question. I am writing here n is greater than equal to 1. Suppose n is greater than equal to 0, means there is nothing. In this condition also you have to write whenever there is nothing. If there is nothing, in this condition also dollar is there, dollar replaced by dollar and move left. Now this is working for it can read all the text. Number of a and number of b are equal. If you will come our class presentation, I will show how I designed the class presentation one by one we solved. Okay, in the class we have written this blank symbol. Okay, and step by step we explain. Okay, this question as well as a ki power n, b ki power n, c ki power n also. Okay, so either this question will come a ki power n, b ki power n, or this question a ki power n, b ki power n, c ki power n, this question will come. Now here what is the question? Here the question is different. What is the question? The question is this one. There is a space, I will see. Okay, there is a space I am writing here. Okay, my question is blank blank blank. There are 3 parentheses, 4 parentheses. Okay, so 1 2 3 4. I am taking on, at first I am solving only this one. So I will start from here again. q0 q0. I will start. So now when this symbol is coming, I will replace by x and move right. I will replace by x and move right. Okay, now I am here. This I replace by x. I am moving. Now I am here. So now at this position q1 is here. There are many this symbol. There are many this symbol. All this symbol replaced by this symbol and move right, and move right. Symbol replaced by this symbol, move right, replace this symbol, move right. Now I am here. I am this position. Once this position is coming, means this parenthesis is coming, then this replace by x and move left, replace by x and move left. Now I am here. So once you are here, I am writing this here. I am writing, okay, because there is no space. Actually this is going here. Now I am writing this transaction here. Now what I am writing, this already we have written. Okay, this transaction we have written here. This transaction we have written here. Okay, now here. So now once you are going, move left. Now you are here. This position. Now once there are many such type of parentheses. What? This all replaced by this and move left, and all replaced by this, move left, move left, move left. Now whenever x is coming, so x is coming, whenever x is coming, x replaced by x and move right, x replaced by x and move right. So you at first what you did, I will write here if you are not able to understand. 1 2 3 4 5 6 7 8. Okay, this I replace by x and this also I replace by x. I move left, I move left, I move left. Now x is coming, I move left, x is coming, x replaced by x, move right. Now I am pointing here. So now I am pointing here means I reached here. This replaced by x, this replaced by x and move right. Now I am pointing here. Now see here, there are many such are coming, all replaced by this and move right. All replaced by this, move right. Now I am here, I am here, but there is x, but there is x, but there is x. Now see here, whenever there is a x, x replaced by x and move right, and move right, x replaced by x and move right. Now I am here. Now whenever this symbol is coming, whenever this symbol is coming, this replaced by x and move left, this replaced by x and move left, this replaced by x and move left. Whenever I go to left side, my left side is x, my left side is x. Now again I will write here, here I will write x replaced by x and move left, x replaced by x and move left. Okay, now I am here. Okay, x replaced by x. Now see here, this replaced by this and move left. Again this replaced by this and move left. Now x is coming, whenever x is coming, x replaced by x and move right. Now I am here. Again same position. Whenever this symbol is coming, replaced by x, this symbol is coming, replaced by x and move right. Now here again this symbol replaced by this symbol and move right, move right. I am here. Now x is coming, whenever x is coming, x replaced by x and move right, x replaced by x and move right, move right. Now I am here. Now whenever this symbol is coming, this symbol replaced by x and move left, this move left. Now I am here, I am here. This again x replaced by x because of this, move left. Again x replaced by x, move left. Now I am here, I am here. Now whenever this symbol is coming, replaced by this and move left, x is coming. Now this x replaced by x and move right because of this. Now I am here, now I am here. So now this parenthesis replaced by x, move right, this parenthesis replaced by x, move right. Now I am here. Okay, I will use another color if you are not able to understand, because digital it is very hard, classroom is very important. So now whenever this is x, actually this is x, whenever x is coming, x replaced by x, move right, x replaced by x, move right, x replaced by x, move right, x replaced by x, move right. Whenever this parenthesis is coming, this parenthesis replaced by x, move left, move left, this replaced by x and move left. When you are moving left, x replaced by x, move left, move left, move left. Now you are here. Okay, so whenever this is coming, replaced by here, now you are here. We have to reach this position, end position. There is a dollar sign. What I will write, the same algorithm I will write. What I will write here, I am writing here. Okay, because there is no space, I am writing here. In this condition, whenever x is coming, x replaced by x and move right. Okay, because all are x, x replaced by x, move right. Okay, now I am here. There are many x, all x replaced by x, move right. Okay, now I am at last I am reaching here. Once dollar is coming, dollar replaced by dollar and move left. Now I am reached here, I reached here. Okay, I reached here, sorry, I reached here. So I read all the text, so it is working also for the parentheses. Okay, this is a final. So maybe it can possible, it can also possible. Okay, there is already some parenthesis, so no need to write this symbol. Whenever there is null, then after then you have to go direct final state. So this is the final answer. Now I will come to the last question. This is very important. This is the last question, and what he is asking, PCP problem, post correspondence problem. If you will see our class presentation also we solved. I am writing this question again. Okay, I already take a lot of time. So what is the question? My question is BA I am writing here my domino. My domino is there is a top, this is the top, and this is the bottom, BOTTOM, bottom. Okay, so top and bottom I am writing here. What is the top? Top is A. What is this? Top is BA. Top is BA. Okay, I am writing this question here. I will not waste your time. BCA, at first BCA, okay, then AAB, then AAB, then CAA, then ABCC. So what is the problem? You have to take many domino. These are the domino. This is the domino number 1. This is the domino number 1. Domino number 1, domino number 2, domino number 3, and domino number 4. Okay, so you have to rearrange. You can take a domino multiple time. Okay, so at last the top of all symbol and bottom of all symbol must be equal. This is my problem. How to complete this problem? So we are using one algorithm. What is the algorithm? You have to take the symbol where top of the stack and bottom of the symbols are same. So both are symbol? No. Both symbol are same? No. Both yes. Here no, and here no. So we cannot take this one, we cannot take this one, we cannot take this one, we can take only this one. You have to take the domino where top of the symbol and bottom of the symbols are same. So at first I am taking this one A and AB. I have taken. Okay. Now next I have taken first. So this cancel, this cancel. Cancel means both are equal. Now what is the bottom of the stack? The bottom of the symbol is B. Now we have to take only the domino where top of the symbol is B. Now check where top of the symbol is B, only one, this one. So I am taking here B and CA. Both must be equal. Okay, and it must be ordered second. So this is at first I have taken second, then I am taking first. So this and this cancel. Okay. Now next, now you can see my bottom is CA. We have to take the domino where top of the symbol is CA. So now you can see there is only one. I am taking this one, CA and A. Done. Now you can see cancel. You can cancel this and this. Done. Now bottom of the symbol is A. We have to take only the domino where top of the symbol is also A. And there is only one. There are many, but I am taking this one. Okay, but I am taking this one. What I am taking? A. I can take either second, or I can take either this one, A, B, C and C. Okay, so which one you should take? Suppose I am taking B, will cancel. Okay, B will cancel. So suppose I am taking A, AB. Okay, this one. So what is this? This is the second one. What is this? This is the third one. Okay, now see here, this and this cancel. Now the bottom of the symbol is AB. I want the top of the symbol is AB. There is only one. Okay, AB. A, B, C and C. Now you can see both are cancelled and C cancel. Order must be same. Now you can see number of the symbol at top and bottom are same. Okay, so what is the meaning of this? This is the solvable, but PCP is not solvable. Why? I will show another example. Why PCP is not solvable? I am taking this example 10101. Okay, this is the famous example. I am taking this one 10101. You can write also ABC, no problem. This is the first domino, Now second is 0 1 1 1 1, 0 1 1 1 1, 0 1 1 1 1, third 0 1 1 1 1, third 1 0 1 0 1 1, 1 0 1 1 0 1 0 1 1. I think that you should check this is correct or not. If you are doing something, then after then problem will start. 1 0 1 0 1, then 0 1 1 1 1, 0 1 1 1 1, 1 0 1 0 1 1, 1 0 1 0 1 1. Okay, now see here. Now I will solve the problem. So what I told, you have to take the domino where top of the stack and bottom of the symbol is same. Okay, now see here, this top and bottom are same. Yes, I can take this one. This I cannot take because top is 0 and bottom is 1. I cannot take. Here top is 1, bottom is 0. I cannot take. So there is only one eligible. Okay, out of 3 only one domino is eligible. So I am taking here 1 0 1 0 1. First domino I have taken. Okay, first domino. I will cancel also. I am using another color. 1 and 1 cancel, 0 and 0 cancel. Now my bottom of the symbol is 1. I want top of the symbol is 1. So let I am taking first one again. 1 0 1 0 1. Let I am taking this one first also. So first what I did, I took first and this is also first. So 1 and 1 cancel. Now you can see the ordered are not same. You cannot cancel this 0 and this 0. You cannot cancel this 0 and this 0 because before 0 1 is here. Okay, so this order here must be also 1, then you can cancel. This and this 0 you cannot cancel. So this is not ordered. So this is fail. Okay, now, so what is the meaning of this? First pass, again I am taking first pass 1 0 1. This was pass already. Okay, so now it means that this and this cancel, this and this cancel. I want such domino where top of the symbol is 1. So 1 is already failed. This is already failed. Top of the 1 is another one is this. Now I will check this is working or not because top of the symbol is 1. Okay, so this is eligible. I am taking 1 0 1. Okay, now 0 1 1, 0 1 1. Now see here, I am using another color. 1 and 1 cancel, 0 and 0 cancel, 1 and 1 cancel. But problem again came. What is the problem? Again 1 came at last, and you know that there is eligible only 3, and 3 will give you again same. What it will give you? 1 0 1 0 1 1. If you cancel 1 1 0 0 1 1, again 1 is coming. So it is working in finite time. So there is no solution. Okay, so this question will, such type of question will come in your exam. Either there is a solution decidable or PCP is not decidable. Okay, but for some problem the algorithm is not solvable. It cannot solve all such type of problem. The algorithm can satisfy for the, it is solvable for the finite problem, not for the infinite problem. Okay, so this PCP is not, this PCP is undecidable problem. Okay, so what he is asking in the exam also, he is asking this question. Now you have to arrange this in your domino. Now you can check, this is BA, this is ABA. Okay, and this is ABA, and this is BA, and this is B. And what is this? This is BAB. This is BAB, and this is BAA, and this is A, and this is ABA. Now check. Now you can check the top and stack. Top and top of the symbol and bottom of the symbols are same. This is not eligible. This is not eligible. This is not eligible. Only one eligible. So you take this one and after then check one by one. Okay. Similarly, you can solve all the question. I think that you understand. So we solved all such type of problems during our class presentation. Okay. Thank you so much. Best of luck for your exam.